All right, everyone. Welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I'm joined by Vinod Prabhakaran. Vinod is a senior research scientist at Google Research. Vinod, welcome to the show.
Thank you, Sam. Thank you so much for having me here.
I'm looking forward to digging into our conversation. We'll be talking about some of your research, which looks at both the way that AI impacts social disparities, but also how AI can be used to study social disparities. To get us started with that, I'd love to have you share a little bit about your background and how you came to work in the field.
Absolutely. Yeah, I come from a more traditional computer science background. Like my PhD is in computer science, where I worked on sort of more research at the intersection of natural language processing and social sciences or society. That's where I kind of started. So I come from a more kind of technical background in that sense. Um, but over time, I've sort of got to this like place where researching at the intersection of like AI in general and society, and where I kind of have like two different research profiles. One is like where I use AI or NLP or machine learning technologies to sort of look at societal disparities, or use them as tools to look at societal disparities. And that's the kind of work that I was doing mostly in the PhD work, as well as afterwards as a postdoc at Stanford. But afterwards, like in the last 3 or 4 years at Google as a research scientist, I've been mostly looking at how social disparities influence like these tools, or like how these social disparities are captured, reflected, and maybe even propagated or amplified through these machine learning and natural language processing tools. So it's kind of like looking at both directions of like this intersection.
And you referenced some of the work you were doing for your PhD. What are some examples of the way that you used AI and NLP to look at social or societal disparities?
Yeah. So, I mean, some of the work was like looking at how workplace interactions, how social power manifests in like workplace interactions. Like that was my PhD work.
Okay.
So, looking at email conversations at a workplace, and like looking at, just by looking at the language used and the structure of these conversations, can you tell who is the superior or who is the subordinates in that conversation? Like, how does power manifest in like how people interact with one another? So, that was my kind of PhD research thesis topic. That sort of got me into this work, which is kind of I'm really excited about. I continue to be excited about the work. Is I don't actively work on it, but right now, but that was where we used these NLP tools to look at racial disparities in police community interactions. This is work I did as a postdoc at Stanford with a bunch of amazing researchers there, in collaboration with social psychologists and linguists and computer scientists, where we had access to body camera videos of about 1 year worth of data from the Oakland Police Department. So it was in collaboration with the police department. And we used the NLP tools to sort of look through this lot of data. Usually this data is looked at as like, if something goes wrong, it's looked at as evidence, whereas we were kind of demonstrating that it could be used as like data to learn from and like understand what is going wrong, potentially in the department or in that particular city. So yeah, we used NLP tools to sort of look at like things like the level of respect, the level of politeness, way the conversations are structured when police officers stop community members for traffic stops, for instance.
So presumably the body camera videos were transcribed, and that's what you applied NLP tools to?
Yes. So the first paper that came out of that work, like we did look at the transcribed data, like we had them manually transcribed and looked at like signals for politeness and respect and so on. But there's also work on looking at the audio signals, like the prosody. I was not actively involved in it, but the kind of frequency and pitch and all those factors might be signals that. So this is a huge project with, like, so many people looking at interesting signals there. I also had some work where we are actually looking at the structure of these conversations, like where police officers, or when did the police officers like give the reason for the stop, right? Like when you stop someone, do you start by saying, hey, I'm stopping you for this and this reason, where is your driver's license and registration, versus basically stopping someone and saying like, hey, give me your license and registration, and then telling. So that sets the conversation in a very different kind of path, and that also we empirically were able to analyze and look at these kind of differences in these kind of subtle ways, subtle ways in which like conversations can be different, and what how that can affect like the later parts of the conversation. So this is ongoing work. Like the researchers at Stanford continue to work on this, and I work on, like, I kind of wrapping up. It's been like 4 years now, but some of the work I'm still involved in. So there's like some work that's going to be coming out from that, like in the near future, hopefully. But yeah, that's an example of a place where these AI tools are used to sort of look at social disparities.
I'm curious how much of the social science side of this work you were involved in or kind of got into, or were you collaborating with social scientists and working on the more machine learning technical sides of it?
Yeah, I love this question because it's something that particular project was such a learning experience for me, to sort of having deeper collaborations with social scientists, like to, and also like having that deep respect for each disciplines, like engaging with the social scientists. It was a very close collaboration. To answer your question, it was a very close collaboration. We had like weekly meetings, and like I went to the it was not like a typical computer science project that I have been part of. Like prior to that, you get this data from somewhere, and then you go into your lab and like go through, munch through the numbers, and like try to come up with like some results, and then like put it in a paper. But this was a very involved collaboration with social scientists, but also with the police department and communities. I didn't actively involve with in fact with the communities there, say, but like our collaborators did have like community workshops and stuff. But I did go to the police precinct, and like chat, talk to the police department, police chief, and like sort of understood like the context of this data. And I even went on like ride-alongs to sort of like be part of like to see how these conversations happen in reality. That I mean that really changed or shapes the way I kind of look at this data. It's not no longer just like ones and zeros. Like it actually has a lot more, brings a lot more meaning to like the data that we are working with. And so yeah, it was. And to answer your question about like the disciplinary collaboration also, like it was a very as I said, like we had weekly meetings, and we had like multiple papers. I was working with like social psychology PhD students, and yeah, and we were in another podcast recently, me and another social science colleague of one of these papers, about like how interdisciplinarity works like in these kind of collaborations, right? Like said, I think in that particular project, like I think one thing that we both mentioned was that there was a deep respect for these disciplines, rather than like the computer scientists coming and like taking away like the data and like going and doing magic. Like it was not that. We were very actively involved in framing the research questions, how we ask the research questions, how we interpret the results. All of that was like in deep collaboration.
And so the more recent work that you're doing, how did the work that you were doing previously kind of take you to the more recent work?
Think the work that I was doing at Stanford, especially in this particular context, kind of got me a lot more sort of aware of, or like a lot more sort of yeah, aware of like the kind of the justice angle of like the social science work, like the disparities and like that human angle to it. And that sort of like and it was around the time that there was conversations around fairness and bias in machine learning models that was just like beginning in 2015, 16, 17 period. So I was in that, like I just happened to be in that space where like I was already working on understanding social disparities, and this is like an important, or like a really cool sort of like way of like looking in the other direction. How does these disparities get into or get captured into these machine learning models? And that's what like sort of like pivoted, or like it wasn't a really pivot, because and I still kind of like have this, I still work on like social sciencey kind of flavored work, but that realization is like how I got into the Google research job that I'm where I am right now, where kind of like the focus at that time was on sort of understanding like these, how these disparities get captured in machine learning models. And that was like the transition, because I was already working at that in that space in the other direction. And since joining Google, most of my Google work, as I said, have been on the other direction, where uh, you know looking at how disparities in data kind of get captured in these models.
And clearly one key place where some of those disparities will get introduced into models is through the that human interface, which is data labeling. And your more recent work has kind of focused on that in particular. Can you introduce us to your paper, your 2021 paper, the issues aggregating human labels? What was the kind of the broad set of issues that you were exploring there?
Absolutely. So I think, yeah, there's a lot of work within the machine learning NLP field in the last few years, looking at like various sources of biases, various sources through which like biases get creeped into the models. It could be coming through data. It could be coming through the humans who are building these models and their perspectives, or limited perspectives about society. But in this particular, so I was always curious about how diverse perspectives in data, be it like data, be it in like people who are building these like models, how does like diverse perspectives like get captured in these like pipeline, right? There's not always like this like one single answer. I mean, we live in a world of like pluralistic world with like so many value systems. If you think about like across the world, there's no one single answer for many of these like questions, and ethics and fairness. What is fair for me may not be what is fair for like someone in a different cultural context, and having a different cultural history. So that motivates my current work. Like largely most of my research currently is in that, kind of motivated from that question of like how do we different perspectives like, or disagreements between like what is right and wrong, gets captured in these kind of interventions. So it's like even when like we intervene on like making things fairer, like how do we do that like in a more pluralistic way? So that's where like this particular paper, work on this particular paper that you referenced, came about. And so we had a paper in 2021 where we looked at this one core thing, as you said, data labeling, which becomes like such a core thing for the machine learning pipeline, where you actually have human raters annotate like be it like images or text content, like for like whatever social construct, whatever construct that you're trying to model. In cases where like whether labeling whether something is a cat or a dog, you can see that like most people would agree, like there might be cases where like people disagree whether something is a cat or not, but like it's a relatively more objective kind of task. But when you ask like someone, oh, is this piece of text offensive, that's you're actually leaning on a lot of sort of aspects of that individual humans, like socio-cultural context and their lived experiences, shape how they feel or how they perceive something to be offensive or not. And so we looked at like a bunch of data sets which kind of capture or attempts to capture such sort of subjective or relatively more subjective tasks, such as like sentiment, whether this is a positive sentiment or a negative sentiment, or offensiveness, like, or hate speech, um, or emotions, like whether this is like something expressing happiness or sadness, or that sort of. So it's like we had around three data sets, around 7 or 8 different like tasks, like these kind of like social constructs that were like labeled, and we looked at how people's like different annotators like perspectives like matched or not. So the traditional way of dealing with like when people disagree for a long time, like, in machine learning, traditionally how you deal with it when people disagree is that you take a majority vote. Like you have, especially when you collect data from the crowd work kind of platforms like Mechanical Turk and all that, it's like relatively cheap, so you get like three annotations for all or 3 or 5 or 10, depending on how much money you have, and you basically get the more number of annotations, and then you take a majority vote to say that, like, oh, this is the majority of people in our pool agreed and stuff. We basically were questioning, like, what does that mean for like perspectives or people with specific sociocultural backgrounds which may be underrepresented within the annotator pool. So we had a paper, like kind of a precursor paper first, where we kind of did this analysis on this 8 different data sets, 8 different tasks, annotation tasks, like where we looked at, like, if you just take the majority vote, and then compare or look at like how does each individual annotator agree with this majority vote, like, because we also have like the annotations that these individual voters gave, like how many times like their vote really made it to the majority, right? So we looked at like that, or was equal to the majority, right? Like we looked at that for these tasks, like that varied significantly across tasks, and sometimes it is like all over the place. Some tasks, like such as hate speech, if I remember correctly, was a lot more kind of like, most people agree, and most people, the majority vote like agreed with like most people. But like there are things like disgust is a emotion, like it had like very wide range of like interpretations, and like people disagreed on that.
One thing that jumps out at me just hearing you describe that setting is, in some contexts you might be tempted to look at the degree to which a particular annotator um, annotates along with the majority as like a measure of quality. But here you're pointing out that it's in fact, maybe a measure of diversity or different context or something like that.
Absolutely. I think predominantly machine learning community have been using that quality kind of framing in doing the majority vote. Like the reason why they do majority vote is to actually remove the noise, right? So I think it probably comes from the place that, machine learning researchers are like, want to ensure the quality of the data that they're working with, and this is like comes across as like noise.
But there's two different things. There's like, in the context of an individual label data point, the taking the majority allows you to eliminate the noise. But then from the context of the kind of the labeling operations, right? Often you're looking at the labeler over time, um and you're trying to understand, which of the labelers that are best.
I've seen work that also looks at like this kind of agreement with majority as a way to like, assess the quality of the rater themselves.
Right. That's what I'm alluding to, and that this now um this additional angle that, hey, it's not just quality. Depending on the type of question that we're asking, it's also a measure of different degrees of diverse perspectives. Yeah.
Yeah. And I think one, I do want to note that, like, yeah, it's possible that it could be an unreliable rater, but if that rater is like internally consistent with their own annotators, like if they see similar things, like again, if they're like, so then they are actually bringing in a different perspective, like that is kind of like, it's not that it is lower quality, it is just a different value system maybe is reflected in their annotations. So that's what we were going after, right? Like, so this is an ongoing project. It's not just one paper would not answer all the questions. um, so in this particular case, we were basically trying to tease apart or disentangle these disagreements and sort of understand um, what factors might be contributing to why people are disagreeing, right? Like, is it just this person being unreliable, just like, randomly selecting things, or is there a systematicity to the way they disagree with the majority, right? And one way in that paper that we looked at was looked at like there was one data set where we also had access to the social demographic characteristics of these annotators. So we looked at whether there is a difference in across like different genders. This particular data set had only binary gender. No, I think there was only one non-binary gender person, so it wasn't like big enough to like analyze all the different kind of gender categories, but it was a gender was one thing, and then political affiliation or ethnicity or race. uh, and in this particular study we show that there was no difference in gender, as in like men and women had like, or male and female annotators had similar rates of sort of like having raters who disagreed with the majority with the in across annotations. But it was interesting to note that like when it came to race, African American raters, annotators like who identified as African American in that data set, had a significantly lower agreement with the majority rating than white American. This was a data set collected in the US, so white American, Asian American raters. So that is a problem. That is a problem when, from a fairness perspective, when you take majority, then you're actually sidelining a particular perspective. Like potentially there is like a perspective that is being sidelined.
What was the particular, the specific data set and task?
So this is a data set for determining sentiment, like positive, negative, neutral sentiment labeling. I do want to note though that this data set was collected with the intention to study biases. So this was not a case where like there was a data set and someone just like did majority vote and then moved on with like in an incorrect way. This data set had the socio demographic information in them precisely because they wanted to study these. This is a dataset built by Mark Diaz, my colleague, for his PhD thesis. So he now works with me. So that's how this dataset had this information. Usually, machine learning researchers, when they collect data for various reasons, like do not collect the social demographic information because it's a much harder to get that information. There's all sorts of risks involved with it. Yeah, so we were able to see these disagreements with the majority that differs across different social demographic kind of groups, which is a even a bigger problem from a fairness perspective, because this is like a human or like a researcher's decision to sort of take the majority vote, and by doing that you're actually actively sidelining certain perspectives like in your data labels. So yeah, that was the work that you referenced, and then we had a follow-up paper that I can talk about where we kind of look at like how we can sort of deal with that, like how we can constructively sort of deal with this like diverse perspectives.
So let's dig into that second paper. You've identified this challenge, and then the second paper wanted to propose some potential solutions.
Yeah. So what we did there was basically, rather than sort of trying to find this single ground truth for like these kind of subjective tasks ahead of the time, like ahead of training these models at the data collection stage itself, like taking the majority vote, rather than doing that, we built a sort of like an approach, or like we built a kind of a machine learning pipeline where we use a multitask approach where it's traditionally used for like you want to train a model for like multiple tasks that are similar, so use the same machine learning network, like the network that you train, like you use the same data, but then you kind of like have this final layers that are trained for specific tasks, so that you have like a shared embedding or shared kind of network for the most of the part, and then like you have like these specific task specific like parts of that network. So we looked into whether we can actually model separate annotators and their systematicity in which like they annotate, like using this sort of like shared network, like a multi annotator model, so that like you have all the data is being used for training like this model, but like this model does not output one label. It outputs like, okay, if it was this person, that person would have said the label X. Or so you have like, if you had like 10 different labels, labelers, like 10 different raters, you actually are modeling these 10 different perspectives in the output. And then in the output time, you can actually take the choice of like, if you still want to do majority voting, like you can do the majority voting at the output. Like, the machine learning model gave like 10 outputs, and you can just take the majority vote there. Or you could say that, oh, we want to take the kind of outputs produced by these subset of annotators, or subset of like these predictions that models like annotators from a particular background. You can imagine a scenario where like you have annotators from like different countries. Let's say there are three countries that we have annotators from: India, US, and like say Germany. And then when you're actually rolling out like products into these societies, like you may want to actually use the majority vote, or like use the vote from a particular region, or like or the machine learning models predictions that reflect that those annotators uh, to kind of to be used in that region. Like, so there are like so many different ways that you can use this approach. So you basically captures this like multitude of perspectives in the prediction pipeline, rather than sort of like suppressing it in the beginning of the pipeline. It also gives you an additional ability to sort of know when there is uncertainty, like when there is disagreement. Like, because if you make a label as a majority label, if you call that, okay, this sentence is offensive, just based on like majority vote, like in the beginning of the data collection itself, we would never know whether that was like agreed on by 10 people, or like two people, right, like, and it was an unanimous decision or not. Whereas in this case, like, you have these like multiple perspectives at the prediction time, so you kind of know that, oh, multiple annotators would have disagreed on this particular case, so maybe the machine should not predict here. It should be like a human labeler from that particular sociocultural context should like make a call whether this particular piece of text is offensive or not. So that's another way I could imagine this being used, is that like it gives you a handle on how much uncertainty is potentially here, how much diverse perspectives potentially is here for this given piece of text.
It's kind of consistent with the general idea in dealing with neural networks to just give it all the data and don't try to clean it up too much, because you end up hiding what you think might be noise that the network can actually find some signal in.
Probably. I mean, that was definitely not the motivation for our us approaching it. But I think, yeah, the current neural networks are powerful in sort of like bringing in these signals, like because prior to this sort of multitask architectures, which is like a 2 or 3 years, maybe a little bit longer old. Prior to that, like you would have had to like train, if you have like five different like set annotators, you have to train like five different models. Like, there's no way that like they have a shared network and they can take signals, like even the smaller signals, like from each of these raters to be like modeled differently or separately. That would have not been possible. So I think the current neural networks ability to sort of like pick up on these signals are definitely contributing to being able to sort of capture this diversity without like affecting like sort of like the end performance, if that's what you're going for.
And so is the model that you're creating based on the kind of the annotator signal, is this then kind of used separately as part of a downstream training task, or are you kind of embedding it end to end in the ultimate task?
That's a great question. I think that there is potential to actually use this as kind of like a lead in for like other downstream tasks. And so to take a step back, like, so this is ongoing work. Like, we have not sort of like rolled it out in like into any products or anything. This is like, I work in research, so this allows in Google research, that allows us to sort of like do this foundational research without having it to be tied to any particular products. So in that sense, like, we have not sort of like rolled it out yet on any of the products. But like, I think I envision this both as like a potential kind of like first step to sort of like tease apart these differences. But it could also work as a sort of end-to-end scenario where, like, I could imagine like an online platform using this model to sort of have multiple answers for like multiple perspectives for sort of choosing whether some particular content needs to be removed or not. For instance, like, it could help in the content moderation kind of pipeline to sort of queue content for review appropriate, like, sort of reprioritize content. And so I could see this being used in like that kind of production scenario as an end-to-end when I say end-to-end, like, I often uh, envision like a human label or a human sort of like intervention. It's a human in the loop or machine in the loop kind of situation, rather than um, sort of like button click and like you kind of like get the label, and like that's that decide like whether something is offensive or not. So there's often a human in the loop is needed. And yeah, in those settings, like, I could imagine this model being useful.
How did you evaluate the performance of the model?
Traditionally, for this data set, like, if you had built like a single kind of label model, like, you would basically go and evaluate the typical machine learning evaluation pipeline. Like, you have like a test set, and you basically look at like the accuracy or precision, recall, and so on. So we evaluated first in terms of basically, if you choose to just still do the majority word, like if you had taken the majority in the beginning versus like this whole pipeline of like this multitask or multi-annotator architecture, which has like these multiple perspectives. And then you take the majority vote and looking at like sort of how well this does in that evaluation. So that using the traditional pipeline to evaluate. And in that case, we were able to see that like the performance was almost the same, or sometimes in some data sets even better. Because better in the sense that, like, because it's modeling each annotator kind of like individually, and it allows it to sort of like look at internal consistency of their labels better than when you actually merge them. So it doesn't happen across board, but like in some tasks, like, it performed even better in that particular evaluation strategy. But we also looked at sort of how well are we doing on calculating this uncertainty. We looked at, are we able to, or the sentences where the model said something is offensive, and like, there was a lot of disagreement in the end. Like, in the end predictions, there are multiple there's more disagreement. We compared that with like how much did annotators for this particular text disagreed with each other, right? Like, so we compared when the model has this high disagreement, is that also the cases where like the annotators originally disagreed. And that turned out to be the case. There was a significant correlation between sentences where the annotators disagreed and the model disagreed. And that kind of and that was a lot more than traditional ways of calculating uncertainty. So this is another kind of way we evaluated. So that was not about model performance, because our focus is not getting like the model performance from like 72% to 74%. Like, that's like the typical sort of like the machine learning kind of research kind of objective. And for good reason. Like, it is important to improve the performance. But in this work, we are interested in like how well we are capturing diverse perspectives, and are when we are having these disagreements in the predictions, are they reflecting disagreements in the actual data, and which turned out to be significantly correlated. So yeah.
Has this research led you to kind of a set of axioms that you would recommend to folks as they're kind of building these labeling pipelines and wanting to create models that are as robust as possible, as fair as possible? Like, how should they think about all these issues?
Absolutely. Yeah. I was there's like, so this work is ongoing, and there's like a lot more work that needs to be done, and this particular model that I proposed is not going to solve all the problems in the space. And so we had like laid out like a bunch of like sort of recommendations in the first paper actually, that like, the traditional practice is that you take a majority vote and sort of like that's what is in the data set. Most people, when they collect labels from like multiple people, they just take the majority vote, and that one label is the only thing that's even in the data set. So we recommend, or we argue that people should, like, when people collect data, should sort of release annotator level data, sorry, individual annotator level kind of labels, so that like you're not treating these annotators as interchangeable anymore. Also, where possible, like sort of being able to collect social demographic information about annotators as much as possible, to do it responsibly. Being able to sort of like release that along with the data set would only enrich that, and sort of the downstream users of this data set could basically use that information to account for any fairness failures or any of these kind of analysis, which is very hard for us to do because most data sets in our community do not have even annotator level labels or like social demographic information. In addition, we also argued in favor of sort of like documenting about the recruitment, selection, and assignment processes that are followed for this annotation kind of pipeline, so that like it gives more information about like how these annotation labels, like what was the diversity of raters, like what like social demographic kind of factors or like groups were represented and what was underrepresented. So those information is super useful for the downstream user of these data sets. So on that note, like I want to also give a call out to a recent paper by my colleague Mark Diaz on sort of providing a sort of comprehensive framework for communicating these things about annotator diversity and annotator these processes through a kind of a transparency artifact called crowd worksheets, which capture these kind of information. And that just got published like a couple of months ago at the Fairness and Accountability and Transparency Conference. So I encourage people to check out that work as well. And I also want to call out that like this the two papers that I discussed at length is work led by my intern Ida Davani, who was at USC at that time last summer. And so this is like almost a year long of work after internship. Like she continued as a researcher, student researcher with us, and she has now joined back as our team as a full-time researcher. So this work is an ongoing effort, like, and one of the core sort of themes of my research going forward.
Awesome, awesome. Well, Vinod, thanks so much for joining to share a little bit about what you've been working on.
Absolutely, this was a pleasure to chat about this research, and it was lovely chatting with you, Sam.
Same. Thanks, Vinod.